Your job today is to calculate how long it would take to charge these phones. And we need to know two things. How fast are you sending electricity to them, right here, the current, and what is the capacity of the phone? So we're going to go to iPhone 11 right here. We're going to do the first one and say uh, battery capacity of iPhone 11. Oh, thank you. So we're going to do that. So I'm just Googling battery capacity of iPhone 11. And then right here it says iPhone, here we go. iPhone 12 and iPhone 12 Pro models share a 2,815 milliamp battery, for example, while the iPhone 11 and iPhone 11 Pro are equipped with 3,110 and 3,000 batteries respectively, meaning that the Pro has 3,000. So we're going to assume it's the iPhone 11, this one, which means it has 3,110. So we're going to just go over here. We're going to say 3,110 milliamp hours, like that. And I'll tell you what in a minute what that. See right here, milliamp hours. What does that mean? Hey, what the heck? Oh, I see. Other people are using this. Wait. Why didn't that write? Oh, there it did. 3100. Wait. 310. There we go. So here we go. This is how many milliamp hours. So this is capacity in milliamp hours. And then, so here's the capacity in milliamp hours, 3,110 for the iPhone 11. But by the way, there's going to be another one and another one. So you don't have to look these ones up because you already have. So these are the iPhone 11s. Now, what does that mean? By the way, let me just make sure I did that right. Yeah, 3110. Okay. So what does that mean? Oh, I see what I did. I just rewrote it somewhere else. So what does this mean? That means that this battery holds this much power, and if it holds this much capacity, so milliamp hours. What that means is 3,110 milliamps for 1 hour. So you could draw 3,110 milliamps of current out of this battery for 1 whole hour before it dies. That's what that means. Milliamps is a thousandths, so that means 3.1. So that's the same as saying 3.110 amp hours. So I'm just moving the decimal place over 3 times, and it's like saying that many amp hours, okay? So we can draw 3 amps, a little over 3 amps for a whole hour before this dies. Now, truthfully, your phone will never do that. I mean, boy, that's a lot of current for a phone. Your phone would be really hot if that ever happened. So I don't think your phone could ever pull that amount of current out of the battery. And it's going to be argued that, well, if you pulled it out slower, the capacity is that much. But if you pulled it out really fast, it's not really this capacity. And we can argue all day about that. But we're just going to go by the numbers. So this battery, according to the manufacturer, it has this much capacity or this much, however, whether you're talking about milliamp hours or amp hours. This is how many amps of battery juice comes out of your phone, how much current in a whole hour before it dies. Now, if you pull more current than that, it will last less than an hour. If you pull less current than that, it will last more than an hour. For example, if you pulled 1 amp of current from your phone, from that battery, it would last 3 hours, and so on and so forth. So you can just do all kinds of combinations. We're going to figure out how long it takes to charge it. So we're putting in 0.96 amps of current, right, in a 3.110 milliamp hour battery. So pretty much we're just going to take, and here's the equation, charge time is going to equal to capacity divided by current, more or less, okay? So what we do is we're going to take charge time is equal to capacity. Now the units have to match up, so I'm going to use this one here after I move the decimal place 3 times, because this is in amps, so I need this to be in amp hours. My milliamp hours won't work. So let's do that. So we're going to take 3.11 and divide it by 0.96. Oops, but I need to do the actual math. So let's do that real quick. Let's get out a calculator. Although I'm in Excel, or Sheets, so it should be able to calculate for me, but I'll do it here. So 3.11, that's how many amp hours this phone is, right? So you just take the milliamp hours and move the decimal place 3 times, and that's how many amp hours. That means you can pull 3.11 amps for a whole hour before it dies. We're going to take that and divide it by how fast we're sending current into the phone, and that's going to be 0.96 and 3.27. So 3.27 hours. Why? How did I get hours? Because remember, the unit here is amp hours, so I'm just dividing them out. So that's how you do it. You pretty much take the capacity in amp hours, so take the milliamp hours and divide it by 3. Most likely your phones, when you look them up online, they're going to be in milliamp hours. Then move the decimal place 3 times, you're going to get the amp hours. Then take that number right here, right here, 3.11, and divide it by the current that was going to the phone. So this particular phone, this iPhone 11, plugging into a 5-watt power supply, with this much current going to the battery, is going to take 3.27 hours to charge. Now, that's assuming that the phone's not using any power while you're charging it, which is not true. So this is not a real number. That doesn't mean for sure 3.27 hours is exactly how long it takes to charge it. This is assuming that it's dead. This is assuming that your phone is using no power at all while you're charging it. And it's also assuming that all the current is getting stored purely and none of it's getting wasted, which is not true either, because we know that because when you're charging your phone, after a couple hours, is your phone still the same temperature? No, it's hot, which means some of that electricity was just getting wasted into heat. So this is not the true tale. This is just saying if everything was perfect, it would take 3.27 hours to charge that phone with that charger, with this charger giving that much current. I'll do one other one with you, one different one. So let's do a Samsung Galaxy Note A20, I guess. So let's go battery capacity of Samsung A20. 3,000, a big battery. Samsungs have huge batteries in them. 3,900 milliamp hours. So this Samsung A20 has a 3,900 milliamp hour battery, which means its amp hour rating is, move the decimal place, 3.990. So that's the amp hour rating. What's the current? 1.55. So we're going to do this equation right here. We're going to do this equation. And all we have to do is take the capacity of the battery. Remember that we take the capacity of the battery and divide it by the current. So the capacity of the battery is 3.99 amp hours. And we were sending 1.55 amps, so divided by 1.55 amps. And we get 2.57. So even though it's a bigger battery, the battery is much bigger than this iPhone. It's going to charge faster with that charger, and maybe even faster because we're not taking into account this voltage difference and whatnot, so we'll not worry about that. So this one's going to be, what was it, 2.57 hours. So that's that one. So here we go, we're looking at all the different phones and how long they take. This one's going to charge even faster. This person's got it on a big beast of a power supply. I don't know what they plugged it into, but that thing's given 2.45 amps, and I've never seen an iPhone take that kind of current. So that thing's going to get hot. That phone is going to get hot, for sure. But it's going to charge really fast, that's also for sure. It looks like most people are plugging into a standard current, but I also noticed that my my iPhone 8, that it takes about this much current no matter what I plug it into. So if I plug it into a 5-watt power supply, I get that much current. But if I plug it into a 12-watt power supply, I also get the same current. So my phone does not like to charge fast. It has a certain rate it wants to charge at, and there's nothing I can do about that. So that's it. You're just calculating the charge time for all of these phones and nothing else.